given all of these things, we can come up with some pretty annoying looking exponent problems. Z to the negative 7th power, and that's all raised to the negative 2nd power, I guess. Not having any of these shortcuts, it would be very difficult to try and simplify this. And simplified means try to reduce the amount of parentheses and no negative exponents. There's a number of different ways to do this. There's no wrong way to simplify this as long as you're doing rules and you're getting somewhere. Like each step that you do in the process is an attempt to reduce it further. So you could reciprocate this negative on the 2 first to get 1 over the blob squared. You would do the power product again and go 3 squared x to the 4 squared y squared squared z to the negative 7th squared. Simplify all that garbage by raising a power to a power. Remember, we multiply them. So then we have 1 over 9. 4 times 2 is 8. Y to the 4th. Z to the negative 14th. And then to finish this up, I'm going to send that z to the negative 14th up top. Z to the 14th over 9x to the 8, y to the 4th. That would be the simplified form of this monstrosity here. A different way we can do power of a product first. I think that's what I would do. 3 to the negative 2nd, x to the 4 to the negative 2nd, y squared to the negative 2nd, and then z to the negative 7th to the negative 2nd. Now we do power to a power, which means we multiply them. 3 to the negative 2nd power is just, I guess I can tell you that that's 9 to the negative 1st power. If you don't believe me, try to work that out yourself using like breaking down. I'll just do it myself, but try it yourself first. Try using power to a power to break it down. Is the same thing as 3 squared to the negative 1st power. Power to a power, we're just breaking it up rather than simplifying it. And then we can do order of operations from there. 9 to the negative 1st power. Okay, cool. You believe me. X to the negative 8. Y to the negative 4th. Z. Power to a power is going to be negative 7 times negative 2. Negative times a negative is a positive. Then we individually reciprocate each of these to get back to there. So it doesn't matter which way you do it. I said I would do it this way. I probably just depends on my mood and what side of the bed I woke up on. I might do it this way. They both led to the same answer. It just doesn't matter. A couple quick little properties. We have a scenario in which, let's say we have x to the 5 minus 5. Like I gave you this problem and I asked you to simplify it. Now you would say that that's x to the 0 using the shortcut. Well, I don't like x to the 0. That doesn't have any meaning to me yet. So prove to me what it is using the definition and then see if we can equate it to something that I do recognize. Okay, so let's do a bunch of x's. I'll keep the shortcut answer over here for reference. But each pair of x's on the top and the bottom would cancel to 1. Anything divided by itself is 1. I guess it would be better... Oh no, we missed one. It would be better to start this out as x to the 5th over x to the 5th. Because that's the shortcut. That's the actual shortcut here. This is going from this to the definition. Sorry about that. I'm sure you're not offended. Anything divided by itself is 1. In fact, we didn't even need to go to the definition. We just look at the fraction. That's equal to 1. So by this example, and in general, if we have x to the 0, it equals 1. That is a property that you can have in your back pocket. Yeah, basically we're saying we're multiplying x by itself 0 times. Well, that doesn't really make any sense. And then we have an obvious one where if we have anything raised to the first power, we're multiplying it by itself once. So it's just itself. We kind of already knew that one. Then we have another property. 0 to any power, we're multiplying 0 by itself however many times we want. Well, 0 times anything is still 0. But what if I wanted to kind of combine these two here? So anything to the 0 power equals 1, and 0 to any power is 0. What is 0 to the 0th power? Well, by this definition, anything raised to the 0 power equals 1. But then here we have 0 to whatever power, that's 0. So is this expression 0 or 1? There's actually no defined answer for this. This is pretty much as bad as dividing by 0, because in order to use this definition, we would have kind of this example here. We would have a bunch of zeros on the top and then a bunch of zeros on the bottom to have them cancel to equal 1. But that would be stating that we have an expression where we're dividing by 0 and then not immediately screaming at the top of our lungs. But if we were to take values that kind of approached, if I put in 0.000001 and I raised that to the 0th power, it rounds it to 1. I hope you can see that, because that would be a lot less dramatic if you couldn't see it. It's dangerously close to 1, and it would... Calculus would say that this is equal to 1. It's considered what we call in math an indeterminate form. But, well, actually just watch this video if you want to find out why. Matt Parker does a really good job of explaining, and I don't think I could do better than that. He does talk about calculus for a hot sec, but just go with it that he's trying to explain what happens if we go like this. A really small number raised to another really small number. What is this equal to? And then what's the next smallest iteration of that equal to? And we kind of continue that and see where the pattern takes us. That's the same thing as what he'll call a limit.